Okay, we're now recording. All right, so we have finished our fourth exam. We've got one more to go. And see, okay, Caitlin, I got you, but I have to get you a little bit later. Okay, so you should have gotten an email back from me about your score. And I also sent the solutions. So you should have seen the solutions also. Okay, we're almost done, folks. This is our last meeting of April. And once we get to May, we're done quick. So we have one more test, exam 5 and a final. There's only 4 sections left, 12.1, 12.2, 12.3, 13.2. Okay. So I would declare this to be 12.1. Okay, I'm hoping for moving every day back up. And if that's the case, then exam 5 will be Thursday the 13th. Okay. And then we have 1 day to review for the final, and then the final exam after that. Okay. All right. And remember, you get to drop 1 exam, and then so we have 1 more exam and then the final exam, and then we're just about done. Okay. So any quick questions about where we're headed, what's going on? Okay. So let's get started. Okay, 12.1. So the major topic for the rest of the course is antiderivatives. Okay. Now, we've done derivatives for quite a while, derivative. Now we're doing antiderivatives. If it sounds like we're going backwards, that's exactly what's happening. Instead of going the derivative route, we're going the antiderivative route. We're kind of going backwards. Okay, so as usual, I'll try to do as many evens here as possible. Let's get started. Okay, so 12.1. Topic is indefinite integrals. Don't know what that means now, but anti-differentiation in my page 739. Okay, so we know differentiation, taking a derivative. Anti-differentiation is going backwards. Okay, but that's such a big word. We will say integral or integration. Okay, so in calculus, in mathematics, when you hear integration, it's this anti-differentiation stuff. Okay, it's going backwards. All right. Let me show you what's going on in the homework. So page 743, 12.1. Got to aim the book a little bit. Okay, starting with problem 5, see that funny looking S that's in front of the problem, and then there's a dx after that. The dx is just there to name the variable. Okay, it could be dt, dy, it just names whatever the variable is. But you have that funny looking S. That funny looking S means you're integrating. Okay, oh, those are evens there. So, well, might as well show you the evens because that's the ones that I'll be doing for the most part. Okay, and then on the next page, let me check my list again. How far up am I supposed to go? So up to 32. All right, so again, see the funny looking S. And then you have some function, and then there's a dx after that. Okay, so that's up to 32. And then 41, 42, 43, no doubt they're word problems. Yes, there they are, revenue. 41, 42, and 43. Okay. So what's going on here? Right, so antiderivatives. Integration means the same thing as anti-differentiation. Okay, so we're going backwards. So the most general form is this: integral of f of x dx. That's the way we say it. That funny looking S is the integral sign or the integral symbol. You have a function and there's a dx there. Don't worry now about the dx. It just names the variable. If there's a t, there's a dt. If it's a w, it'll be a dw. So the way you read this is the integral of f of x dx. Okay. Here's the meaning. The meaning is give a class of antiderivatives of f of x. Okay, I know that doesn't make any sense right now, unless you've seen calculus before. Give a class of antiderivatives, a whole bunch of antiderivatives. Let me show you what a typical answer looks like. A typical answer is some other function, capital F of x plus c. C stands for a constant. Okay, so the vast majority of these problems is going to be a plus c at the end. Okay. Now, the first couple of problems, I'm just going to show you the answer. I'm not even going to tell you how I got it, but I'll just show you why it's the answer. Okay. So number 2, integral of 5x to the 4th dx. So we're not asking for the derivative of 5x to the 4th, which would be what, 20x cubed. I'm asking for antiderivatives, plural, of 5x to the 4th. Okay, so here's what the answer looks like. X to the 5th plus c. C is any real number. So it could be 0, in which case the function is x to the 5th. It could be x to the 5th plus 1, plus 2, plus 3, plus a million, minus a million, plus pi, or whatever. Okay, these are a whole bunch of functions that have the property that the derivative of any of these is 5x to the 4th, right? Okay, so what's the derivative of x to the 5th? 5x to the 4th. What's the derivative of x to the 5th plus 1? Still 5x to the 4th, because the derivative of 1 is 0, right? So again, I could have any constant here. About x to the 5th minus 20, the derivative is still 5x to the 4th, right? So the first thing you will notice is that when I go the antiderivative route, it's not just one function, it's many functions. Okay, so before we had a function, we just say, give me the derivative, meaning there's only one, there's one and only one. But now we have many antiderivatives, but they all differ by a constant. Okay, so that's what we mean by give a class of antiderivatives, a whole bunch of antiderivatives, not just one, which is x to the 5th. Okay, x to the 5th plus c in general, where c is any real number. Okay, so you have an infinite set. Okay, the derivative of any of these functions, plural, is 5x to the 4th. Okay, let me show you number 4. Okay, again, without really showing you how to do it yet, but I will shortly. Okay, integral of x to the 4th dx. Okay, so again, I'm not asking for the derivative, antiderivative. It's going to be x to the 5th over 5 plus c. Okay, don't worry right now about how I got it. Okay, let's take the derivative of this. So derivative of this, 5 comes down, hits the 1/5, cancels out, so the coefficient becomes 1. Then you have x to the 4th. And the derivative of any constant is 0. Right? So again, we're not asking for the derivative of x to the 4th. We're asking for, and the language should not be the antiderivative. It's many, so a whole class of antiderivatives, but they differ by just a constant. So the derivative of any of these infinitely many functions, plural, where c is any real number, is x to the 4th. Okay, this was not actually a homework problem, but I'll just show it to you. Integral of 7 dx. And here's the answer, 7x plus c. Why is this the answer? The derivative of any of these functions is 7. Okay, so again, we're not asking for the derivative of 7, which is 0. We're asking for antiderivatives of 7, 7x plus c. That includes 7x, but it includes 7x plus 1, 7x plus 2, 7x plus 3, 7x minus 3, 7x minus a million, 7x minus pi. Any of those have a derivative of 7. Right? Okay, so now that leads us to the power rule for integrals. Okay, so I'm just about to show it to you, but let's just think about what makes sense. We have a power rule for derivatives, right? If I have, let's say, x to the 5th, then you should know what to do. So, oh yeah, 5 comes down, multiplied by 5, subtract 1. So guess what happens for the antiderivative? Instead of subtracting 1, what do you think happens to the exponent? You add 1. And instead of multiplying, you divide. So here's the power rule for integrals. And you can put this on your next cheat sheet. The integral of x to the n dx is x to the n plus 1 divided by n plus 1 plus a constant. as long as n is not equal to -1. Okay, you say, what's wrong with -1? Well, if -1 plus 1 is 0, you're going to divide by 0, and that's a no-no. Okay. So you might say, what do I do if there's a -1? We'll show you later. But for now, here's the new power rule for integrals, which makes sense. You do the exact opposite of what happened for the derivative, right? For the derivative, like this, right? You say, oh, multiply by the 5, subtract 1. So do the opposite. Instead of subtracting 1, you add 1, x to the n plus 1 divided by n plus 1 plus a constant. Okay. And let me just see if I can show it to you in the text. Yeah. Page 740. Same thing. Integral of x to the n dx, x to the n plus 1 over n plus 1 plus c for n not equal to -1. What's wrong with -1? If you plug in -1 in the bottom, you have -1 plus 1, which is 0. You're never supposed to divide by 0. Okay. So most of these problems aren't that bad, I think. So with this new power rule, how do you integrate x to the 5th? X to the 6th over 6 plus c. Okay. And you may leave it like this, but if you want to write it as a coefficient, this is a little bit cleaner. 1/6 x to the 6 plus c. Okay. We can double check by taking the derivative, right? What's the derivative of this? Right. You already know the derivative of any constant is 0, so I don't have to worry about that. The derivative of this, 6 times 1/6 is 1, is it not? So you have 1 x to the 5th, which is the same as x to the 5th. So there we go. Okay, that basically shows you how to do the rest of the problems. That's basically it. Now, the only thing that makes it harder is maybe if you have a fraction, involving square roots or negative exponents. A little bit tricky, but that's the main topic. This is the main topic for this section. Integral of 16x to the 9th. Leave the 16 alone. Do this no power rule. Add 1 and divide by the new exponent. So 16x to the 10th over 10 plus a constant. Don't forget the plus c. In general, that plus c does belong there. And reduce this fraction. 16 over 10 reduces to 8 over 5. So final answer, 8/5 x to the 10th plus c. How can I check my answer? Take the derivative. Okay, we're going the antiderivative route or integral. This is the integral sign. You say, I wonder if I did it right. Take the derivative. What's the derivative of this? So 10 times this fraction. Let's see, 10 divided by 5 is 2. 2 times 8 is 16. X to the 9th. Yep, it works. And we already know the derivative of any constant is 0, so it definitely checks. So you can always check your answer by differentiation, right? So check any integration. Integration means anti-differentiation with differentiation. Okay, number 10. A little bit of a trick question. Integral of 5 squared plus x to the 10th. Okay, they're trying to trick you into going 5 to the 3rd over 3. But you don't do that for this case. You have to remember, oh yeah, 5 squared is 25. It's a constant. So that's just like integrating 7. So what's the integral of a constant? Constant times x. So integral of 7 is 7x because the derivative of 7x is 7. So I'm taking the integral of 25 plus x to the 10th dx. Okay, so the integral of 25 is 25x because the derivative of 25x is 25. And the derivative of x to the 10th, x to the 11 over 11 plus c. So that's this new power rule that we have right here. And there we go. Okay. I hope you agree this is not that bad. It's basically just one rule. The power rule, x to the n plus 1 divided by n plus 1, plus a constant. Don't forget that plus c belongs in just about all the problems. Okay, there's maybe only 1 or 2 problems that don't have the plus c, and I'll show you when that happens. Okay. Oh yeah, and if you have a constant, the integral of a constant like 25 is 25x. Okay, what happens if you have a fraction like 12? Integral of 8 plus x to the 2/3 dx. Okay, so you see we're going backwards. We're not asking for the derivative of the function. We're saying what functions are there up here whose derivative ends up being this. Okay, so the integral of 8 is 8x. Integral of x to the 2/3, you add 1. So 2/3 plus 3/3 is 5/3. So x to the 5/3 divided by 5/3 plus c. Okay, but you don't leave your answer like this. Okay, it looks too weird. Okay, then just recall, if you divide by a fraction, you multiply by the reciprocal. Okay, so that's the way you should write it. 8x plus 3/5 x to the 5/3 plus c. Okay, and in fact, this is not that big a step. You all know that from arithmetic. Okay, you're all very good at arithmetic because you've already had at least 2 algebra classes and now math 75 and some other math classes maybe. So I will normally go straight from here to here. That's not big a step. I would just say x to the 5/3 divided by 5/3, and then I say, oh yeah, if I divide by 5/3, I multiply by 3/5. So from now on, and I'll let you do the same thing, I'll jump straight from here to here. Okay, instead of wasting extra time and saying, oh, divide by 5/3, quickly multiply by 3/5. Okay. All right, here's the next one. Integral of 3x squared minus 4x minus 4. Now, the original problem had 4x, but of course, keep in mind that x is like x to the 1. So in red there means it wasn't in the original problem, but I put it there. All right, so that should do it. So 3x squared, 3x cubed over 3 minus 4. Now, this is x to the 1, right? So I add 1 to the exponent, bump it up by 1, and divide by the new exponent. So 4x squared over 2, and the integral of -4 is -4x plus a constant. And then just clean it up. That's x cubed minus 2x squared minus 4x plus a constant, c. Okay. How can I check my answer? Take the derivative, right? We're going backwards, antiderivative. Okay. So if I went antiderivative, if this is correct, the derivative should be the original. Let's check. What's the derivative of that? 2x squared. What's the derivative of -2x squared? -4x. What's the derivative of -4x? -4. What's the derivative of any constant? 0. So it works. Okay, get the idea? Okay, 16. Integral. Funny looking S is the integral sign. Okay. Integral sign or integral symbol. So what's integral? Integration. Anti-differentiation, but this is such a big word. Change the integration. Okay, integral of 12x to the 5th plus 12x cubed minus 7. Okay, so do the power rule. 12x to the 6 over 6 plus 12, right? The rule is you add 1 and divide by the new exponent. 12x to the 4th over 4. Then the integral of a constant like -7, -7x plus c. And simplify. 2x to the 6, 12 divided by 6 is 2. 12 divided by 4 is 3. 3x to the 4th minus 7x plus c. Double check your answer. You say, how do I double check my answer? What should I do with this answer? Take the derivative. See if I get that back. And you already know the derivative of any constant is 0. Like c represents any constant, any number. 0, 25, pi, square root of 2 over 2. Anything you feel like. You already know it's the derivative of 0. Okay, what's the derivative of that? 6 times 2 is 12, x to the 5th. Yep. What's the derivative of that? 4 times 3 is 12, x cubed. Yep. Derivative of -7x is -7. It works. Okay, 18, the original looked like this. 17 plus the square root of x cubed dx. I snuck in the 2 to keep in mind that it means square root. So I have to change it to a fractional exponent now, right? So the fraction is power over the root. So 17 plus x to the 3 halves. Okay, so remember it's power on top, root on the bottom. Okay, the way I remember is the root, like the root of a tree, root of a plant is down, right? So the further down one is the root, this is the power. Okay, then we got it. So integral of 17, 17x. And yeah, I'm going to do that same shortcut that I talked about over here now. Okay, so x to the 3/2, add 1, x to the 5/2, right? 3/2 plus 2/2 is 5/2, divided by 5/2, but dividing by 5/2 is the same as multiplying by the reciprocal 2/5. So there's my answer. 17x plus 2/5 x to the 5/2 plus a constant c. Okay. All right, that's the way it works. Okay, a few more. 20. 3 times the cube root of x squared. 3 times the cube root of x squared. So write it as a fractional exponent, 3x to the 2/3 power. And now I do the same thing. So leave the 3 alone. X to the, okay, so by this new rule, I add 1 and divide by the new exponent. So what's 1 more than 2/3? 1 and 2/3. 5/3. Divided by 5/3. But dividing by 5/3 means multiplying by 3/5. And then clean this up. So final answer, 9/5 x to the 5/3. Now you might say, how do I double check that answer? Okay, let's take the derivative. You don't have to worry about the c, right? The derivative of c is 0 automatically. That's no big deal. Okay, so if I take the derivative, I take that times that, right? So 9/5 times 5/3. If I multiply 9/5 times 5/3, the 5s cancel out, don't they? 5 cancels out. I have 9 divided by 3, which is 3. X to the 5/3 minus 1 is 2/3. There it is. It works. And of course, by algebra, it's the same as that. Okay, 22. 6 over x to the 5th. So when you have the x in the bottom like that, can you guess what happens? Bring it up as a negative exponent. So 6x to the negative 5th is what you want to do. Okay. So in order for you to use this power root, x to the n, you can't have the x in the denominator. If it's in the denominator, bring it up in the numerator and then go from there. So the original was 6 over x to the 5th. Bring the x to the 5th upstairs, 6x to the negative 5th. Okay, add 1. 1 more than negative 5 is negative 4, right? 6x to negative 4 divided by negative 4 plus c. Clean it up. I'm not supposed to have any negative exponents in my answer. So negative 6/4 is 3/2. And then x to negative 4 on top means x to the positive 4 on the bottom. Okay. Okay, 24. The original said 2/5 square root of x cubed. Let me show you that one. 24. 2/5 square root of x cubed. But I sneak in a 2 just to remind yourself it means square root. All right, it's in the denominator, which means negative exponent, and the exponent is power over root 3/2. So 2/5 x to the negative 3/2. Okay, power on top, root on the bottom, and since this whole thing was in a denominator, it's a negative 3/2 now. Okay, so integrate. What's integrate? Anti-differentiate. Integration, anti-differentiation. Okay, leave alone the 2/5. Add 1. X to the negative 1/2. Negative 3/2 plus 1. Negative 3/2 plus 2/2, right? Negative 1/2 divided by negative 1/2. Dividing by negative 1/2 means multiplying by negative 2. So this comes out to be negative 4/5 Negative a half exponent means square root on the bottom. So final answer, negative 4 over 5 radical x plus c. That's nothing. That's just a stray mark. Sorry about that. I'll just cover that up here. So best final answer, negative 4 over 5 radical x plus c. Okay, I'm finished with that side of the paper. So I'll do my focusing thing. So raise it up in case it wasn't focused. Okay, then the middle one. So all that. There we go. Okay, so we don't have that much more, folks. So what do we have left? 26, 28, 30, and a word problem. Okay, and surprise, I was going to give you a quiz today. Okay, but I think you should find this is not that bad, right? So I'm not ready for a quiz. This is pretty easy. Open book, open notes. You can discuss it, right? You can ask for anything more, right? Okay, so I was going to do 26, 28, 30, 32, and then 42. And that's about it. Okay, 26, x cubed, that should be easy, minus 7, minus 3 over x to the fourth. So again, when the x to the fourth is in the bottom, bring it upstairs as x to the negative 4, right? So x cubed minus 7 minus 3 x to the negative fourth dx. Okay, so that shouldn't be too bad. So integral of x cubed, x to the fourth over 4. Okay. Makes perfectly good sense. This power root makes sense. It's exactly the opposite of what you did for the derivative, right? Okay. How do you take the derivative of x to the fifth? Oh yeah, multiply by 5, subtract 1. So you just do the opposite. Instead of subtract 1, you add 1 and divide by the new exponent. So x to the third becomes x to the fourth over 4. Integral of negative 7, negative 7x. Okay, minus 3 x to the negative 3 divided by negative 3. Okay, the negative and negative becomes a positive. The 3's cancel out. So leave that alone, except why I write it as a coefficient of 1/4. Okay, so 1/4 x to the fourth minus 7x, and then bring that x to the negative 3 back downstairs. So final answer, 1/4 x to the fourth. If you leave it as x to the fourth over 4, I'll take it. Minus 7x plus 1 over x cubed plus a constant c. And that's it. Okay, so even though I'm giving you a quiz today, it should not be that bad. I hope you'll find. Yeah, I'm expecting most of you to get the full 5 out of 5. Okay, 28. Integral of 3x to the 8th plus 4 over x to the 8th minus 5 over 5th root of x. That's a 5 there. 5th root of x, I sneak in a 1. This is good. Here the x to the 8th is on the bottom, so what should I do? Bring it up as a negative exponent, x to the negative 8. And this one, the fractional exponent is 1 on top, 5 on the bottom, and it's negative because the whole thing's in the denominator. So x to the negative 1/5, right? Okay, power root, and negative because it's in the denominator. Okay, so leave that one alone. That's 4x to the negative 8 minus 5x to the negative 1/5. Okay. 3 x to the 9 over 9. 4 x to the, careful, you're adding 1. Adding 1 is not negative 9, it's negative 7. So x to the negative 7 divided by negative 7 minus 5. Okay, so here you just have to be careful for the arithmetic. What's 1 more than negative 1/5? What's like saying 1 minus 1/5 is 4/5, right? So x to the 4/5 divided by 4/5 divided by 4/5 multiplied by 5/4. All right. And there you go. Okay, so that reduces to 1/3, right? So 1/3 x to the 9th minus 4 over 7 x to the 7th, negative exponent, put it in the denominator. And then 25, 5 times 5 is 25 divided by 4, minus 25 fourths x to the 4/5. And there we go. Okay, just a few more problems and I'm finished. Number 30, x cubed plus 1 squared times x dx. This is a product. So you might say, why don't I just do the product rule? There's a very good reason. There's no such thing as a product rule for integrals. So all I'm gonna do is just multiply it out. X cubed plus 1 squared, that's like a plus b squared. A plus b squared is a squared plus 2ab plus b squared. So I square this, x cubed squared, or x cubed times x cubed, x to the 6. Plus 2ab, 2 times x cubed times 1 is 2x cubed. Plus b squared, 1 squared is 1. Okay, so now I take all this times x, and then I'm ready to integrate. So x to the 6th times x is x to the 7th. 2x cubed times x, 2x to the 4th. 1 times x is x, which is the same as x to the 1. All right, then I'm good. All right, so x to the 7th, x to the 8th over 8th. 2, x to the 5th over 5. X to the 1, x squared over 2, plus c. And nothing cancels. You can leave it like that. Again, if you want to write it as a coefficient, as 1/8 x to the 8th, that's fine. Or 1/2 x squared. But I'll leave it like this just to show you that it's possible to do that. Okay, and then 32 is also a little bit different. It's a quotient. 32, x minus 3 over radical x. You might say, why don't I just do the quotient rule? There is no quotient rule. Okay. There's a product rule and a quotient rule for derivatives. There is no product rule or quotient rule for integrals, antiderivatives. So what am I going to do? I'll just divide through. I'll just take that divided by that minus that divided by that. And keep in mind, radical x means x to the 1/2 power. Okay. So this is x to the 1 divided by x to the 1/2. So I subtract the exponents. 1 minus 1/2 is 1/2. And this one, there's really nothing to do except x to the 1/2 is on the bottom. So I bring it upstairs as a negative 3 x to the negative 1/2. So this is what I'm integrating. And here we go. Add 1, 1 plus 1/2, 1.5, or 3/2, x to the 3/2 divided by 3/2 means times 2/3. Minus 3, x to the, so add 1. What's negative 1/2 plus 1? Positive 1/2. X to the 1/2 divided by 1/2. Divided by 1/2 means multiplied by 2. And there we go. A little bit of cleanup. Leave that alone. 2/3 x to the 3/2 minus 3 times 2 is 6. X to the 1/2 means square root plus c. So there's my final answer. 2/3 x to the 3/2 minus 6 radical x plus c. All right, that's everything up to 32, folks. I just have one word problem and then I'm done. Then I'll give you a quiz. Okay, let's see. Let me check the chat. Okay. Final exam is going to be on the 20th. Okay, that's for certain. So it won't be on the 25th. Okay. Yes, we still have an exam 5 and a final to do. Exam 5 is on the 18th. Okay, why capital F? Right, so I think you mean over here. If this doesn't answer your question, that's fine, and ask again. So little f. So we know what to do to take the derivatives, f prime, f double prime. When I go backwards, it's like I take off a derivative. So I take off and prime, but there's no way to do that. So we write it as capital F instead for the antiderivative. Okay. Meaning capital F prime is little f of x, okay, if that's what you mean by that. But otherwise, yeah, there's no big deal between that. Okay, and let me see, check the chat. Yeah, so let me clear up the dates again. So I'm going to aim for exam 5 on the 13th and final exam on the 20th. Again, when I first printed this out, I thought the final exam was on the 25th. It isn't. It's back to 20th. That's why I had to try to gain a date over here, and I've sort of been able to keep up with that right now. Okay, so hoping for 12.1, 12.2, 12.3, 13. We just move all these up one day. Okay. All right, 41, 42, 43, and then I'm finished, and I'll give you the quiz, and we're done for the day. Okay, they're all very similar, so I'll show you 42. 42, the marginal revenue, MR, is negative 0.05x plus 25. Find a revenue function. Okay. 41 looks very similar. 43 looks very similar. So before it was, here's the revenue function, find the marginal, i.e. derivative. Now we're going backwards. Here's the marginal, what's the original? So instead of differentiation, I'm going to anti-differentiate. Okay. But these have a little bit of a twist. Okay, so I'm going to show you that right now. Okay, so one more time, this is not the revenue function. Not that long ago, we said, okay, here's the revenue function, find the marginal revenue. Oh yeah, take the derivative. But this is backwards. This is the marginal revenue. So the MR there, that's the marginal. This is the answer for a derivative problem. What was the original function, right? So we're going backwards. So the revenue function is the integral of negative 0.05x plus 25. Okay, and that doesn't look too bad. So negative 0.05 x squared over 2 plus 25x plus c. And then divide this by 2. Negative 0.025 x squared plus 25x plus c for r of x right now. But I'm not quite done. Okay. So this is the original function as of now. And check. If this was the original revenue function, what is its derivative, i.e. what is its marginal? So the derivative is negative 0.05x, there it is. Derivative of 25x is 25, there it is, plus c. So it does work. Okay, but there's one extra thing. So remember, I mentioned at the beginning, I said almost all these answers are going to be plus c, except for one case. Here's the one case where there isn't going to be a plus c. Okay, it's a revenue function, right? So here's a revenue function. If I sell no items, how much money am I going to make? 0, right? So I'm in business. I sit around and do nothing and don't sell anything. My revenue is going to be 0. In other words, R of 0 is going to be 0. So if I put a 0 right there, I put a 0 right there, plus C, the answer is going to come out to be 0. Okay, one more time, R of 0. The revenue, if I sell nothing, I'm not going to make any money, right? So I put a 0 there, that's 0. Put a 0 there, that's 0. So I have C equals, the revenue should be 0, which means C is 0. So for this kind of a problem, 41, 42, and 43, there's no plus C. Just drop the C. The revenue function is just negative 0.025x squared plus 25x. So that's the only exception to the rule. And that's the same thing for 41 and 43. The C is going to be 0 because it's a word problem. And we know if I sell nothing, the revenue should be nothing. I mean, think of it this way. It doesn't make sense. Suppose this came out to be 7, right? Blah, 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 plus 7. That means if I sell nothing, I still get $7. That doesn't happen, right? Someone's kind enough to come up to me and give me money for free, but that normally doesn't happen. right? Okay, so for this kind of a word problem, no C, just leave it like that. Okay, I'm finished, folks. So I'll do my focus thing. If anybody has any questions, you can put it in the chat right now. Otherwise, I'll give you the quiz and we're done for the day. Okay, so we're done with this. We only have 3 more sections. If I can keep the schedule, this is Tuesday of next week, Thursday next week, Tuesday the following week. And that lands us on exam 5, review for the final, and we are done. Okay. All right, so if you have a question, put it in the chat right now. And if not, we'll go straight to our quiz. So let me do my focusing thing while you have some time to put something in the chat if you want to. Or you can unmute yourself also. On that. And that's it. Okay, so let me check the chat if there's anything. And I don't see anything else in the chat. I think I answered the question about the test and final exam and all that. We're good to go. Okay, any other quick questions? Otherwise, we'll go straight to the quiz. All right, so get your cell phones out and be ready to do a screenshot. Okay, I hope you'll find these aren't too bad. Okay, find the following integrals or antiderivatives. Number 1, integral of 4 plus 2x minus 3x squared dx. Number 2, the integral of 3/2 radical x dx. So obviously you have to change the radical x into a fractional exponent and go from there. Okay, it should not take you that long, but once you get it, don't leave. I have to set up your breakout rooms and get it and all that stuff, but that shouldn't be too bad, hopefully. Okay, so I will assume everybody has it now. If you don't have it, get it in the next 10 seconds, or else ask one of your breakout room mates for it. Number 1, integral of 4 plus 2x minus 3x squared dx. Number 2, integral of 3/2 radical x dx. Your answer should have a plus C. All of these should have a plus C, a warning. Okay, so I'll stop the share. So go ahead and get started.